Welcome to the Math Axon. This is the PYQ series of GATE where first time I will go with the linear algebra. There is the GATE 2018 question of linear algebra with 2 marks, where you can see that let A should be the matrix of 3 cross 3 where A, B, C, F are real number and F not equal to 0. The geometric multiplicity of the largest eigenvalue of A equals in the matrix A, B, C, which is real and F should be a non-zero. Then we know that this ABCF are real and this is symmetric matrix. So this matrix should be, we can say that this is a real symmetric matrix. What is symmetric? You know that very well. A dash equal to A. When we the transpose of the matrix and then become same a matrix, then so we can say that it is a symmetric matrix. Now we conclude this question with the A, B, C should be 0, take A, B, C should be 0 and F should be 1. Then we make a new matrix. Then we generalized about the eigenvalues of this matrix and his geometric multiplicity. Let A, B, C equal to 0 and F equal to 1. Then the change in a matrix implies A should be 0, 2, 0, 0, this is 1, this is 2, 0, 3, 0, 3, 0, 3 cross 3. This is the real symmetric matrix. Now we find the eigenvalues of this matrix. So we go with this rule of linearly independent and dependent and trace and determinant of a 0, not find the equation of this matrix. We conclude this question with this linearly independent, dependent and trace and determinant helps. Now we know in the given matrix 0 2 0 2 0 3 0 3 0 3 cross 3 where second first and third row should be LD. Then we know that when the matrix and LD and vectors are row 1 and row 3 are LD, so determinant of this matrix A should be 0. So then we concluded one eigenvalue should be lambda equal to 0 and trace of A also 0. Then we know that sum of eigenvalues should be trace. Then one eigenvalue of the on this relation where lambda should be 0. So lambda 2 plus 3 equal to 0. Then we know that then lambda 2 minus lambda 3. This so that ki one eigenvalue should be 0 and one is positive and one is a negative with same magnitude. Then this so that eigenvalue should be distinct. Eigenvalue will be distinct. Then A is a diagonalizable. Then am and gm of a is equal. Then we find of largest eigenvalue, so am should be 1, lambda should be 1, then am of gm are of 1 and gm should be, where we know that am is a algebraic multiplicity, where am, how to find am, where the how many times the eigenvalues repeated, where lambda should be repeated at one time, so the largest eigenvalue lambda equal to 1, and there gm also 1. So largest eigenvalue geometric multiplicity is 1. Then the right answer of this question should be 1. गेट 2018 के सेकंड क्वेश्चन में हम लोग देखेंगे लीनियर अलजेब्रा है. कंसीडर द सबस्पेस W1 equal to ordered pair x1 x2 x3 belong to RQ such that x1 equal to x2 plus x3 W2 of RQ, then the dimension of a W1 plus W2 equals. Basically in this question two subspace given W1 plus W2 and finding the dimension of W1 plus W2. Then we know that the free variable condition x for W1 for W1 condition is given that x1 equal to x2 plus 2x3. There is only one choice when you find only two choice x2 and x3, then you find x1. So we can say that there is a two free variable, you can choose two values x2 and x3, then two free variable in the W1. Also W2 have two free variable. Then W1 and W2 have a dimension to respectively. Now we find the dimension of W1 intersection W2 because of dimension of W1 plus W2 equal dimension of W plus W2 minus dimension of W intersection W2. Basically you can find the value of this, then you conclude the question. Now dimension of W intersection W2 you can find with a help of free variable. You can put this equation x1 equal to x2 plus 2 x3 and x1 equal to 3x2 plus 2x3 in a form of ax equal to 0. Then you find a matrix form of these two equations, which is like that. This is the metric representation of these two equations. Now we can find with this matrix pivot and free variable. You can convert into echelon form. Then you find 1 0 minus 1 minus 3 minus 2. It's a minus 2. It's a minus 2 and 0. Okay. There is a 2 pivot. You can divide minus 2 in second row, then you convert the matrix in 1 minus 2, 0, 1, 0. Then this is a pivot and this is a pivot. One free variable exists. One free variable exists, which is the dimension of the given matrix. Then dimension of W intersection W2, it should be 1. The dimension of W plus W2 equal dimension of W1 plus dimension of W2 minus dimension of W intersection W2. Then you could find also dimension of W1 plus W2 and intersection also, which is given like that: 2 plus 2 minus 1, which is 4 minus 1, it's a 3. Then the right answer of this question, it should be 3. तो हम लोग अब नेक्स्ट क्वेश्चन देखेंगे जो गेट 2018 में लीनियर अलजेब्रा में आया हुआ है. Let V be the real vector space of all polynomials of degree less than or equal to 2 with real coefficient. मतलब हमको एक in this question given that polynomial of degree less than or equal to 2 कि polynomial की जो डिग्री है वो आपकी 2 है. Okay, let T such that V to be a linear transformation given by Tp is equal to 2p plus p dash or p belong to V, where p dash is the derivative of p. Derivative मतलब differentiation of p. Then the number of non-zero entries in the Jordan canonical form of a matrix of T equals. In this question, the number of non-zero entries. Find the number of non-zero entries in a Jordan canonical form from a matrix of a T equal. So firstly we find the matrix representation of this Tp equal to 2p plus p dash with the help of basis of degree less than or equal to 2 with the help of 2 degree polynomial. Then we know that the standard basis of 2 degree polynomial, which is basis is 1x x square. We can use this basis for the metric find the base coordinate of for metric representation. Then Tp equal to 2p plus p dash implies that p should be 1. Then t1 equal to p is the polynomial, this is the constant polynomial. Then 2 into 1 plus p dash should be 0 because differentiation of a constant is 0. Then 2. Then its a coordinate is 2 0 0 with the help of standard basis 1x x square. Then find tx, which is also 2x plus differentiation of x would be 1. Then its coordinates for metric representation, it should be 1 2 and 0. Now tx square is equal to 2x square plus p dash should be 2x. Then coordinate of this 0 2 and 2. Then for the matrix representation, change the find the matrix representation. Then the coordinates should be changed right in the column of the matrix. Then we conclude that matrix representation should be of this Tp equal to 2p plus p dash is where this is the coordinate, first coordinate, second coordinate, and the last in the second page is the third coordinate. It's a 2 0 0 1 to 0 and 0 to 2. 3 cross 3, which is the matrix representation of this equation tp equal to 2p plus p dash. Then find the, so that this is the, sorry, this matrix is a upper triangular matrix, so the diagonal entries is the eigenvalue of this matrix. So there is a 3 eigenvalues which is repeated. There is a 1 eigenvalue which is repeated. Am should be 2 of is 3, and we find the gm of this equation for the Z1 canonical form of this matrix for a Z1 canonical form. Then find the gm of a 2. It should be a 1. Because of find, how to find gm is a n minus rank of a minus lambda I, which is, where is a rank of a minus lambda I is it's 2, so 3 minus 2 it should be 1. Then the gm of 2 is 1. Then gm, sorry, gm of 2 is 1. Then the Jordanical canonical form had only one block, which is 3 cross 3 order. Then with eigenvalue 2, because of there is a one gm which is so that there is one linearly independent vectors, and Jordan canonical form make by the Li vectors, Li eigenvectors. So gm given the how many eigenvectors in the equation, so gm should be 1 for each eigenvalue. Then so we conclude with the eigenvalue. Then what is the Jordan canonical form? It should be 2 1 0 0 2 1 0 0 2, 3 cross 3, which is Jordan canonical form. In the question, in the given question, find the number of non-zero entries. This is the Jordan canonical form, JC form. Then you can conclude with the number of non-zeros entries in this matrix 3 cross 3, which is 2 1 0 2 1 2. How many? 2 1 2 3 4 5. There is a number of non-zeros entries is a 5. So the answer is a 5 of this question. 5. This is the 2018 PYQ. In 2017 also this type of question where is a find non-zero entries, but not where that not given this equation. Give the am and gm, then find the matrix of representation. You can find this question in my playlist of GATE PYQ 2017. Now go with the next question of this series. GATE 2018 में आया हुआ सवाल लीनियर अलजेब्रा का 2 मार्क्स में, where s such that m2r tends to m2r by sx equal to 2x plus x transpose. This line is so that we find then the trace of s equals, firstly in this question we find the trace of the matrix. So for the trace we find matrix of this by the help of sx equal to 2x plus x transpose. In this question s says that m2r tends to m2r, which is so that there is a 2 cross 2 real matrix with entries real. Then we find the standard basis of 2 cross 2 real matrix, which is like where the standard basis is a form of 0 1 0 0 0 1 0 0 and 0 0 1. This is the four values of the standard basis of 2 cross 2 real matrix. This basis elements of Li elements, we find the matrix representation of 2 cross 2 matrix representation of Sx equal to 2x plus x transpose. So firstly we use T110. With the help of this, sorry, yes, 110, we apply Sx equal to 2x plus x transpose, then X should be 100, which is the standard basis element. Then we can get 2100 plus x transpose, then the matrix should be changed 100. Then what is sum of this two matrix is a 3000. Then the change in the coordinate form, which is like that. For first it should be 3000. It's the first column of the matrix representation. Now for second, which is given that x transpose should be 0 1 0 0. Now sum of these two matrix, which is like that 0 2 0 0. Then its coordinates like that 0 2 0 0. Now similarly go with third basis element, which is like that 0 1 0 0. Then there is a x, not t. It's change in 2 0 0 1 0 plus x transpose should be 0 1 0 0. Now sum 0 1 2 0. Yes, it's a coordinate like that 0 1 2 0. Now similarly for fourth elements of the basis, where s 0 0 0 1, then it's change 0 0 0 2 plus transpose is similarly, then sum of this 0 0 0 3, and the coordinate of this 0 0 0 and 3. Now we conclude that the matrix representation should be by the coordinate which is in a column. Then matrix should be 3 0 0 0 and 0 2 1 0 0 1 2 0 and 0 0 0 3. This is the matrix representation of Sx. Then you find the trace where 3 4 3 5, which is 10. Then the trace, sorry, sum of all diagonal elements, it's a trace. Then trace of, we can say this is A matrix. Trace of A should be sum 3 to 5, 2 plus 3 is a 10. The right answer of this question, it should be 10.